All right, so let's see what else we can do with this API. So I'm back here at the documentation, and if I click along sort of this navigation bar, I did want to show you that there is a way to search just by name. So if for some reason you wanted students or teachers to be able to access the information about just a particular element, they would use this API endpoint. So let's go back into our code. I think it was what, /element /atomic name. So /element /atomic name. And how about our friend Xenon? Same thing here. Once we change the API endpoint, this all stays the same. And I'll just get rid of all this output, run our code, and we get just the information about Xenon. Okay. So let's just go back and change this to elements and, get all of our elements. But let's not actually print them out because that is, as we saw, a lot. Maybe that's too much. Maybe we want to do something like just print out all of their names. Let's start with that. So remember, our information was returned to us as a list of dictionaries, just like our student example from before. So we're going to iterate over that list for element in all elements. Okay. And then for each element, what do I want to do? I think I just want to print out that element's name. So element sub name, right? That's how I access the value associated with that key. And there I have my list of all the elements, and that might even be all 118 from the database. Maybe I want to print out their name and their, let's see, I don't know, electronic, is that a thing? Let's see, electron affinity. I'll be honest, I don't know what that is, but suppose you wanted to print that out. You could do something like print out elements name, comma, element sub, what was it? Electron affinity, I believe. Now, of course, if we make a spelling or capitalization error, we're going to get an error, but that's okay. Deal with that. And there we go. Apparently, we have a lot of unknown electron affinities. But here we see germanium with its electron affinity of -119. So you can kind of customize your output, print out what you want. This would be a fun thing. We could give students some starter code and then have them adjust it, little bits here and there, make some tweaks to print out different information about the elements. So that's one cool thing. And then when I talked to Lauren about this, I just actually saw her at the office a few minutes ago and we were chatting and she said, well, what about, if you wanted to know all of, I don't know, again, I'm making stuff up here, all of the elements that are gases and have a certain electron affinity, or sort of create custom filters like this. So there's no one API endpoint that's going to give you that information. So that's where we're going to have students actually tweak a little bit of Python and do some real coding. So let's do that. So let's say I want to print out only the elements whose, what's an example here, whose atomic radius is greater than 150. Whose atomic radius is greater than 150. So I'm going to iterate again over my list. So for each element in all elements. And now I'm going to need an if statement. So if that element's atomic radius is greater than 150, I'm going to print out that element. Let's just print out that element's name to keep our output short. Okay, let's run it. You know what, maybe let's delete our output and run it again. All right. Oh, okay. So if you noticed before, there are a lot of unknowns in the database. And I think some of the elements, for whatever reason, have an unknown atomic radius. So you can imagine the computer's a little bit confused because imagine a particular element has an atomic radius of unknown. So then Python is trying to compare, is the word unknown greater than 150? And it's confused. That question doesn't even make sense. So actually, I'm going to adjust the code a little bit. I'm first going to make sure that the atomic radius is not unknown. So if the element's atomic radius is not equal to unknown and is greater than 150. So I can explain that code to you in more detail, but basically I had to put a little check here to make sure that the radius is not unknown before I check that it's greater than 150. So let's run that. And there we go. We have the elements whose atomic radius is greater than 150. If you wanted to be sure, along with the name, you could print out the element's atomic radius. Let's run that. And there we have it. Those all do appear to be greater than 150. So I'll stop there and I'll let you play around with, again, making these requests to the API. So getting either the entire list of periodic elements or some subset of that list, and then creating some custom filters like this. And again, we won't have students writing this code from scratch, obviously, so you also should not feel like you have to write it from scratch. But I'm happy to go over any of this in more detail with you at some other point. But hopefully this was a good sort of foundation and enough to get you started and also to get your juices flowing about how we might have students use this information from the API. So I'll leave it there and I will talk to you soon. Thanks, Tess.